Alright everyone, welcome back to our arcade vehicle tutorial. This should be the last part. So lastly we just have lateral slipping, turning, and some drifting to get into our vehicle. So first off, I have some variables here that we'll need. So for our lateral slipping, we have a float for tire mass for each tire. A turn torque, which I have a very, very large number, which I'll talk about in a minute. Steering input, grip factor, which will be used for drifting, and then a boolean for is drifting. So first thing is make sure you have an input action for turn, and make sure it's a 1D float, so that in your mapping context, you can have it set up to whatever keys, but you could have left and right turning. And then on the left turn, make sure you add a modifier with the plus sign and then negate it. So it'll be a negative value. All right. And then if we go into our event graph and we go to IA turn, we are going to, similarly to the brake and throttle, we're going to set our steering input with Alt, and then we can also just add a torque in radians, and this is going to be the box component that we want to apply this to, and then split the pin, struct pin for the torque, as we only want to apply it on the Z direction. So then we want to multiply this by our turn torque and put it in the Z. And that should be turning. Let's test. Yeah, there you go. We have turning already. But as you notice, you can turn when you're completely still. So in my case, for my vehicle, that was actually something I wanted. So if that's something you want, leave it in. But if it's not, then we can add a branch in here with holding B to shortcut that. And we can say if the brake input is 0, or the acceleration, we're going to duplicate that, Control D, and bring acceleration input. So basically we could say here, if the brake input is 0 or the acceleration input is 0, then don't allow turning. So if we try that, we can still turn. Oh, not equals 0. My apologies. Greater than 0. Greater than 0. That's, yep. Because if it's greater than 0, then that means we're either accelerating fully or we are braking, so we are moving. Otherwise, yeah, there we go. So now I'm pressing A and D, no turning. I go forward, I can turn now. So there you go. But as you can see, we are slipping quite a lot because we don't have the actual lateral slipping yet. So that would make sense. All right, now that we have that, we can go into, we're gonna set this up for a drifting while we're here in the event graph. You can make an input action for this as well, but for my case, I'm just gonna put a spacebar here for now, and we're just gonna set our is drifting to true, and then duplicate that with Control D and set it to false whenever we release that. Okay, now let's go into our handle wheel forces function, and then I've already made a function here. I've called calculate lateral slipping. So let's hook that up with our current wheel, compile, and then let's hop into that function. Make sure you have, as the other functions, the current wheel as an input, and it's a scene component. And then to get started, I should probably quickly go into my amazing paint again. So what is lateral slipping? Essentially when your vehicle is turning, or let's start more basic. So if this is like a top-down view, imagine this is a wheel right here. The wheels like to go forward and backward, but not right and left. That's like that indicates slipping, unless you want drifting. So to kind of counteract this, when a vehicle turns, this is a wheel of like a front wheel turning, for example. This would be the front direction, this would be the right direction. And the dot product of that is essentially the desired like velocity where we actually want to go. So we're going to be using a dot product to find that. And then what we want to do is basically apply a force depending on like the current dot product velocity. We want to apply a force in the opposite direction, either like on this axis, either left or right, depending on its velocity, to counteract that slipping so that we can actually turn with more control. So yeah, okay. Now if we go back into our function, first thing I'm going to do is actually a sequence node, because every frame, the first thing we want to do is have a branch and check if we are drifting. Oops. Make sure you do a get with control, because if we are drifting, I'm going to set our grip factor to different values. So grip factor of like 0.1, and if we aren't, I'm going to have like 0.5. And these obviously depend on how much control you want to have. I would recommend between 0 and 1 to make it make more sense, but yeah. Okay, now we need to do that dot product I talked about. So if we get the linear velocity at a point, because we want the velocity at a component from the hierarchy down here, and and plug that into the point. So now we're getting the linear velocity at that wheel, and this I'll control D that. In the dot product this time, I want to find the right vector is where the slipping force is, essentially the force that we want to this. We want to multiply by -1 to get the opposite directional force of that. And then we'll also take our grip factor into account, so that if we are drifting, we'll have less force applied to it. Then we will divide by get world delta seconds to make sure that FPS does not affect it. Okay. Want to multiply the tire mass. There we go. Sorry. Our tire mass, as well as the direction to apply the actual force. So get current wheel, get right vector. Boom. Okay, so here's our force. I will be honest, I'm not entirely sure if this tire mass is necessary or correct, or if it should be like tire mass divided by 4, or if we should take into account the mass of the actual chassis or not. But for me, this has worked like very well. So if anybody has a comment on that, please let me know, but it's worked well for me. So, and I'm gonna actually go into our braking function just so I can copy these nodes for the add force and go back into lateral function and paste it. Try and make it a little bit nice. Let's connect the nodes, and the force goes here and here. And then this should probably be like a little bit 0.1. And then let's change the color. All right. And yeah, I think that should be good for now. And then just so you have it, for me, my tire mass is like 5 kilograms. That's obviously going to depend a lot on what you're using, but just for now, for our box, this is fine. My turn torque is actually very, very large. I think, what is this? 1 million, maybe 10 million even. And steering input is just what we'll be setting. And then grip factor, I just set to 0.5 as my normal for now. And then one other thing you can actually do as well is if you go into your box, you can search up damping and you can change your angular damping. So because my turn torque is so high, for me it was easier just to crank it up super high and then change the damping to affect this. So the higher the damping value, the less it will be prone to like rotations in general, but for in our case the turning of the yaw. So now if we test, as you can see, the red lines are going. So when we're just moving forward and backward, there's not really any force applied, which is correct. And then if we start turning, as you can see, there's forces in that direction, and now we can actually turn properly with more control. And then if we turn the other way and back and forth, then we get some nice turning action. And if I hold space, I can turn a little bit. I get a little bit of a drifting. You would definitely have to kind of mess around with these values, but as you can see, I come to a much more slidey stop if I hold and then I let go. So obviously this is going to be more effective at higher speeds, or if you have the grip factors a lot more varying values. Mine's just 0.5 and 0.1. And it also depends on the mass of your actual vehicle as well, because if it's a lot heavier, then things are going to affect it more. So yeah, and that's our turning, our drifting, and our lateral slip. So that's pretty much it, all I have. There's the base of a arcade vehicle that I made in Unreal 5.5. So if you have any questions, please let me know. If you want me to actually go into like how to apply the mesh to it and how I adjusted variables to make it work for my specific mesh and the wheel trace locations and stuff like that, just let me know. I can do that. But for now, this should be at least a little bit of something to get you started, hopefully, without using Chaos plugin. So if it helped, I hope it helped, and thanks for watching. See ya.